Okay, so we are waiting for Evan and Jared. So once ready, turn on the video. You can hear me, right? Both of you? Hello, Heidi. Hi, Fiona. Okay, so the guys are not here yet, but let's just start because it's 7:30 already. Okay, so have you gotten back your paper, Fiona, for your WA? Not yet. Okay, once you have gotten your paper, do let me take a look. Then I can see Evan is here. Now, we are starting a new topic today, but I think some of you probably find this very familiar. Either your school your school has already taught you this together with the elements, mixtures, and compounds. Okay, some schools choose to do that. If you have not too sure whether Fiona, you have gone through this already, but I think for the rest of you, Heidi, Jared, as well as Evan, if you recall, we have done something similar to this topic, like the molecules of elements, molecules of compounds, right? Then we also explore the periodic table, how to identify, the period, okay, where is the group, etc. Okay, now, learning outcomes. So MOE expected the students to learn all this. Okay, this is the new syllabus, which is what you are currently doing. Okay, so you need to describe an atom as an entity that is electrically neutral. So this term is important, electrically neutral. Okay, it's made up of positively charged nucleus with protons and neutrons inside. Okay, and then the negatively charged electrons are moving around the nucleus in their electron shells. Okay, so recognize that atoms have mass that is mainly contributed by the mass of the nucleus. Then show awareness that atoms of an element have unique number of protons. Okay, how to identify number of protons, I'll be teaching you soon. Show understanding that molecule, okay, so this is something that we have learned, okay, is made up of two or more atoms chemically combined. So for molecules, there are two types: molecules of elements, molecules of compounds. So if you are talking about molecules of elements, right? Example will be, let's say, nitrogen gas. Okay, so this, it must draw same size as much as possible. Okay, so this is N2, this is nitrogen gas. Two or more atoms chemically combined. They are the same type of atoms, so we call them molecules of element. So of course, we also have molecules of compounds. Molecules of compounds will be atoms, okay, of different elements chemically combined together. For example, water. So this is one molecule of water. It's made up of hydrogen and oxygen atoms. Okay, so you should be able to remember all this by now. Then state the numbers and types of atoms. For example, if I were to have this particular formula, C6H12O6, okay, the numbers and the types of atoms. Types of atoms will be the different elements that it consists of. So there are three types here. We have carbon, we have hydrogen, and we have oxygen. So if you are looking at these types, right, how many of each are present? So there are actually 6 atoms of carbon, 12 atoms of hydrogen, and then 6 atoms of oxygen. Can see that? So all these exist in one molecule of this sugar. Okay, this formula stands for sugar. Okay, and then this is just one molecule. If they ask you questions like how many atoms are there, how many atoms and types are there in 3 molecules of sugar, what will your answer be? The types should remain the same, right? Because the types are still going to be carbon, hydrogen as well as oxygen. But if you are talking about the numbers now, okay, number of atoms now, since I'm talking about 3 molecules, this is 1 molecule, right? And when it becomes 3 molecules, I think it's pretty obvious. Okay, all this will be just multiplied by 3. Any questions? No? Good. So let's move on. So this is a very quick recap, but let's see. Okay, let me look at this part here. Okay, so compare the size of atom with the sizes of everyday object. No need to compare, they are so small. You can't even see them at all. Now, let's go on to what is inside an atom. Okay, scientists found evidence that atoms are made out of subatomic particles, mainly the electron, proton, and neutrons. They have their positions inside the atom. So you cannot just anyhow place them, right? Inside the atom, okay, right in the center, we have the nucleus. In the nucleus exist the protons and the neutrons. The electrons are actually in the electron shells, okay, surrounding or orbiting around the nucleus. So if you go on, you will see this. Okay, so they call it the dense center. That is the nucleus. Then can you see all the different colored circles here? So each color represents one type of the subatomic particle. So this blue one represents the proton, and the pink one represents neutron. Okay, so surrounding nucleus, a cloud of electrons, they move at nearly the speed of light because they are so light, as in they are not heavy, you know. Okay, so their mass is so small, they can move extremely fast. So atoms are electrically neutral. You need to know electrically neutral. Just now, I also circled in the learning outcomes. So electrically neutral, why? Because the number of protons is equal to the number of electrons. What is the meaning of this? Okay, let's explore further. If you look at this now, subatomic particles, 3 types. Okay, I usually refer to them as TEN, 10. T for proton, E for electron, and then N for neutron. Okay, so you must know about the electrical charges. So electrical charges involves what? It involves the either positive or negative, or is it going to be 0? So if you look at this table, it's a quick summary of things you need to know for this chapter for the subatomic particles. So again, subatomic particles, you have proton, okay, and then you have neutron and you have electron. Now, they are represented by a certain symbol, small letter P for proton, then the small letter N for neutron, and electron is just a letter E. Okay, do you need to put the negative sign? Okay, depends on your school. I will accept even if you just put down the E. Okay, relative mass, no units. Okay, so no units is already telling you it's relative. So it's compared to something else. That's why we don't put down grams or kilogram because they are too light, you know. It's not possible for us to even put it on the weighing scale to measure its mass. So we are comparing with something else. Okay, so in this case, just put down the mass of a proton as 1. Okay. Then the neutron is 1 also. Just now I mentioned electrons move almost at the speed of light because it is not heavy at all. It is too light. Look at the mass. If you were to calculate, use your calculator, okay? Take 1 divided by 1836 and tell me what is that value. Okay, it's going to be so obvious to you. It is extremely light. Heidi, you finished this topic already? Not yet. Okay, do y'all try to calculate? If you try to use the calculator, key the values in, 1 divided by 1836. You should get a very small number. It will be 0.00 something. Yeah, so this gives a value of 0.00 5, 4, 4, 6, 6, 2, 3. So comparing the proton, neutrons, and the electrons, can you see how light it is? Almost negligible, isn't it? It's so close to zero, right? So just remember, there will be some books that will tell you it's 1840. Okay, please stick to 1836. Over the years, we see some fluctuation. And then I see that recent years, or for many years, it is consistent. 1 divided by 1836. Don't take the one with 1840. Can? Okay, so now I'll talk about charges. You see that I actually put a bracket or I circled the entire thing. Okay, why did I do this? Because charges are important. Every proton carries a charge of +1. Okay, so usually when we say that there are 3 protons, right, then the charges will be +3. Okay, and then for the neutrons, every neutron carries 0 charge. The word neutron seems to remind you of the word neutral right now. So neutral means 0 charge. So even if I have, like, let's say 5 neutrons, the charges will still be 0. Okay, so we talk about electrons now. Electrons are negatively charged. So if let's say I have 3 electrons, I'm writing too low already, I think. That's fine. Okay, I put down here, if it's 3 electrons, okay, the charges for the electrons will then be a total of -3. You all can see that? Okay, so depending on the number, so every electron carries a negative charge, a 1 minus. Okay, but when we are talking about, let's say, 10 electrons, then the charges for the electrons will be -10, etc. Okay, let's go on. So that's the meaning. So revisit the periodic table. If you have your periodic table with you, it will be very useful. Look at your periodic table now. You should be able to see that there's a key there, right? To indicate to you proton number and then the nucleon number, also known as the mass number. Okay, so this is also called the mass number. They also call this the atomic mass number. That's fine. So long as you know that they have a few names, but they are all about the same thing. Okay, and then the one at the top is the proton number. So if you visit the periodic table, hold on, let me open up my periodic table. You all should have one with you. Periodic table. All right. So every time you look at the periodic table, there is a key. It says proton bracket atomic number. Okay, so this is the one. So proton bracket atomic number. Then you have the atomic symbol, the name of the atom. Then after that, the relative atomic mass or atomic mass. That's fine. Okay, so this number at the top tells you it is the proton number. And then the one at the bottom is the mass number. Okay, so this is what they are trying to say. And that's what I'm trying to mean also in the slides. Okay, let's go on. So what do these numbers represent for beryllium atom? In this atom of beryllium, okay, take note because the number over here at the top stands for the proton number. So it means it represents the number of protons in an atom. So it is the number of protons in an atom. Pretty straightforward here. So what is this meaning? Okay, take note, they also call it the atomic number. It's fine. So we know that number of protons equal to the number of electrons, right? Just now earlier we said atoms are electrically neutral. What's the meaning of electrically neutral? Let me work this out for you. We talk about the proton having 1 positive charge each, right? So in this case, if I talk about the charges for the protons, okay, it's going to lead to what? Because there are 4 protons, okay, it's going to be a +4. Do you see that? Okay, because 1 proton carry 1 positive charge, 4 protons will carry +4 charge. and the electrons are negative.